Hello, my name is Bradley and today I'm going to talk to you about human immunity. The human body has many things to help protect it from infection. Probably the most obvious one is the skin. Skin is the largest organ of the body and also acts as a barrier to infection. Not only does the skin function as a physical obstacle, but it is also an unfriendly environment for many microbes. The skin's surface is slightly acidic and some areas are quite dry. Neither condition suits many microbes. Skin consists of three main layers: the epidermis, the dermis and the subcutis, each of which contributes to the skin's protective abilities. The outer layers of the skin form a barrier against environmental influences. The external layer of the epidermis are made up of dead cells embedded in epidermal lipids and covered by a hydrolipid film. The lower layers of the epidermis are also responsible for the production of vitamin D, which protects us from rickets. Epidermal lipids are responsible for binding in moisture and creating skin's permeability barrier, helping to prevent bacteria and viruses from penetrating the skin's surface. The hydrolipid film, an emulsion of water and lipids which covers the surface of the skin, also acts as a further barrier against toxins. The acid mantle, which is a water part of the hydrolipid film, gives the skin its mildly acidic pH, the perfect environment for skin-friendly microorganisms known as skin flora to thrive and harmful microorganisms to be destroyed. Inflammation is a biological response of body tissue to harmful stimuli, such as damaged cells, and is a protective response involving immune cells, blood vessels, and molecular mediators. The function of inflammation is to eliminate the initial cause of cell injury, clear out necrotic cells and tissues damaged from the original insult, and the inflammatory process is to initiate tissue repair. The main signs of inflammation include pain, heat, redness, swelling, and loss of function. There are 7 natural body openings or orifices providing access to internal cavity through a natural passage called a canal, duct, or meatus. So from the top of the body down, we have the ear canal, the entrance to the nose, the nasal passage, the mouth, and the opening of the urethra. Mucous membranes are what helps protect our orifices from infection. Mucous membranes form the moist pink lining layer of the mouth, throat, nose, eyelids, urethra, vagina, and digestive system, and also act as a partial barrier against infection. These membranes normally help protect us from germs in the air which we breathe, our environment, and in our food and drink. Typically, mucous membranes are coated with secretions that fight microorganisms. For example, the mucous membranes of the nose are lined with small blood vessels that help to warm and humidify the air which we breathe. The mucous membranes are also lined with cilia, tiny hair-like structures that help trap the debris that we breathe in. This is an important function of the immune system and keeps germs out of the body. The lymphatic system is a vascular network of tubules and ducts that collect, filter, and returns lymph to blood circulation. Lymph is the clear fluid that comes from blood plasma, which exits blood vessels and capillary beds. The fluid becomes the interstitial fluid that surrounds cells. Lymph contains water, protein, salts, lipid, white blood cells, and other substances that must be returned to the blood. The major components of the lymphatic system include lymph, lymphatic vessels, and lymphatic organs that contain lymph node tissues. The thymus gland is the main organ of the lymphatic system. Its primary function is to promote the development of specific cells of the immune system called T lymphocytes. T lymphocytes are responsible for cell-mediated immunity, the immune response that involves the activation of certain immune cells to fight infection. A lymph duct is a great lymphatic vessel that empties lymph into one of the subclavian veins. There are 2 lymph ducts in the body, the right lymphatic duct and the phocratic duct. The right lymphatic duct drains lymph from the right upper limb, right side of the thorax, and right halves of the head and neck. The phocratic duct drains lymph into the circulatory system at the left brachiocephalic vein between the left subclavian and the left internal jugular veins. Lymphatic vessels transport lymph to lymph nodes. These structures filter lymph of pathogens such as bacteria and viruses. Lymph nodes also filter cellular waste, dead cells, and cancerous cells. Lymph nodes house immune cells called lymphocytes. These cells are necessary for the development of human immunity and cell-mediated immunity. Macrophages play a key part in immunity and immune response. They take a defensive role exhibited by their ability to carry phagocytis of parasites and microbes. They regulate lymphocyte activation and proliferation, and they are essential for the activation of T and B lymphocytes by antigens and allergenic cells. Now we know about immunity, let's talk about acquired immunity. Acquired immunity is the immunity that our body gains over time, similar to how an individual gains knowledge over time. However, our body learns how to target and destroy specific pathogens only when these pathogens invade our body. This knowledge and action performed by the body forms the acquired immunity. Unlike natural immunity, acquired immunity doesn't have natural barriers. However, what it does do is generate specific chemicals, also known as antibodies, that neutralize the harmful toxins produced by the pathogen. Each specific type of pathogen requires a custom chemical to neutralize it. A toxic or other foreign substance which induces an immune response in the body, especially the production of antibodies, is called an antigen. Sensitization is a process by which the immune system will produce a defensive protein called an antibody in response to a substance it considers abnormal, including certain foods, pollen, mold, or medications. An army is a force of people fighting together. The immune system is just like that, except it's a collection of cells fighting together. The immune cells are the soldiers that defend our bodies from invaders. Just like the different soldiers have different jobs, so do the immune cells. Natural killer cells look for a problem within our cells. If it looks like a cell has been infected by a virus or a cancer, the natural killer cells move into action. They release chemicals that destroy the damaged cell. Eosinophils are similar to natural killer cells because they don't engulf their prey. These cells are found near mucous membranes and look for things like parasites. They then release enzymes that destroy any foreign dangers. Dendritic cells are a link between the innate and the adaptive immune system. They are sentinels that look for peculiar threats near the skin. If they find something, they then eat it, but then bring it to a lymph node and deliver it to the adaptive immune system. Immunoglobulins, also known as antibodies, are glycoprotein molecules produced by white blood cells. They act as a critical part of the immune response by specifically recognizing and binding to particular antigens such as bacteria or viruses and aiding in their destruction. There are 5 primary classes of immunoglobulins: IgG, IgA, IgM, IgD, and IgE. They are each distinguished by the type of heavy chain found in the molecule. Differences in heavy chain polypeptides allow them to function in different types and stages of immune response. For example, the IgA class protects mucous membranes. To be effective, the immune system must have the ability to discriminate between self and non-self cells in the body. Those identified as non-self, for example bacteria, are attacked and destroyed by the immune system. When an organ transplant is introduced to the body, the immune system recognizes it as a foreign material and therefore attempts to attack and destroy it. It is this immune response that leads to transplants being rejected. When a transplant is carried out, therefore, immunosuppressive drugs must also be administered to prevent the body attacking it in an attempt to introduce tolerance of the transplanted organ. The rejection of a transplant is primarily due to the immune response to the T lymphocytes, also called T cells, which attempt to attack and destroy any foreign material in the body. After being stimulated by the presence of an antigen, the T cells reproduce by mitosis, producing a large number of cells which can attack the foreign material. Therefore, most immunosuppressants work by interfering with their cells multiplying. Active immunity results when exposure to a diseased organism triggers the immune system to produce antibodies to that disease. Exposure to the diseased organism can occur through infection with the actual disease or introduction of a killed or weakened form of the diseased organism through vaccinations. Either way, if an immune person comes into contact with the disease in the future, their immune system will recognize it and immediately produce the antibodies needed to fight it. Active immunity is long-lasting and sometimes lifelong. Passive immunity is provided when a person is given antibodies to a disease rather than producing them through his or her own immune system. A newborn baby acquires passive immunity from its mother through the placenta. A person can also get passive immunity through antibodies containing blood products such as immunoglobulins, which may be given when immediate protection from a specific disease is needed. passive immunity only lasts for a few weeks or months. Herd immunity is a form of indirect protection from infectious disease that occurs when a large percentage of a population has become immune to an infection, thereby providing a measure of protection for individuals who are not immune. Isolating a person who is seriously ill and living in a community is vital, as isolation restricts the movement of ill persons to help stop the spread of certain diseases. Quarantine can also help limit the spread of communicable disease. Isolation and quarantine are used to protect the public by preventing exposure to the infected person. There are many factors which can influence the way a person's immune system responds to a vaccination, such as the age in which the first vaccine is delivered, the sex of the person, and the spacing between doses. Variation in these and other factors leads to better immunity in some people more than others. Infants are provided with a degree of protection against disease in the first few months of life due to an inherited antibody from their mother. Like everything else in life, vaccines are not completely risk-free. However, in the case of all the vaccines used in the current UK routine schedule, the overwhelming evidence is that vaccinating is safer than not vaccinating. However, if someone is very unwell with a high temperature, it is a good idea to put off vaccinating them until they have fully recovered. This is so that symptoms of the illness do not get confused with a reaction to the vaccine. Over the years, various vaccines have been analysed over their effectiveness at combating the disease it was designed for. Studies have shown that 2 doses of MMR vaccine are about 97% effective at preventing measles, mumps and rubella. 1 dose is about 93% effective. Centers for Disease Control conduct studies each year to determine how well the flu vaccine protects against a flu illness. While vaccine effectiveness can vary, recent studies show that flu vaccination reduces the risk of flu by between 40 and 60% among the overall population during seasons where the most circulating flu viruses are well matched to the flu vaccine. The hepatitis B vaccine is very effective at preventing hepatitis B. The hepatitis B vaccine is very effective at preventing hepatitis B virus infection. After receiving all 3 doses, hepatitis B vaccine provides greater than 90% protection in infants, children and adults immunized before being exposed to the virus. When your immune system doesn't work the way it should, it is called an immune system disorder. Immunodeficiency disorders can affect B lymphocytes, T lymphocytes or phagocytes. The most common immunodeficiency disorder is IgA deficiency, in which the body doesn't produce enough of the antibody IgA, an immunoglobulin found primarily in the saliva and other bodily fluids that help guard the entrances to the body. People with an IgA deficiency tend to have allergies or get colds more and other respiratory infections, but the condition is usually not severe. Autoimmune disorders are where the body's own immune system attacks itself as foreign matter. In autoimmune disorders, the immune system mistakenly attacks the body's healthy organs and tissues as though they were foreign invaders. Cancers of the immune system happen when cells grow out of control. This can also happen with the cells of the immune system. Allergic disorders happen when the immune system overreacts when exposed to antigens in the environment. The immune response can cause symptoms such as swelling, watery eyes, and sneezing. There are several ways of reducing the risk of an allergy. Contact allergies such as eczema, which is actually something I suffer with myself, are best avoided by avoiding any particular triggers. For example, if someone is allergic to dogs, then it's best to avoid touching dogs. Other allergic reactions, such as hay fever, can be avoided by taking medications such as antihistamines, which reduce or in some cases completely remove symptoms. More serious allergies, such as a nut allergy, are controlled by certain medications, such as an EpiPen. And although coming into contact with the allergen cannot prevent an allergic reaction, using medication should stop any reactions a person is suffering. Thank you for watching my presentation on human immunity. My name's Bradley. Have a good day.